My name is Mr. Cosmas. We are going to discuss network analysis as a topic for discussion now in this particular class. So we shall start by understanding what network is all about. And thereafter, then we shall be look at questions to see how you are able to go about answering the network analysis. Now, first, we get to understand what network is. And networks just a combination of activities. It is a combination of activities. Dummy activities, and events. Logical sequence, logical according to the rules of drawing network. So that is the network we are talking about here. So that is the network. So it's a combination of activities, events in logical sequence according to the rules of drawing network. So it means that there are rules which are followed in drawing network. And so when we talk about network, it's just a combination of what we are seeing here. So this network, it may be, for example, in a project like actually putting up a house, there are several activities or jobs that are to be done, and a combination of them all will actually make up the overall house. So, for example, if you want to put up a building, you will be having several jobs that will be done in the. So the job will start with that of digging the foundation. Then we can have the walls, and we have the roofings, and we have the finishing. So these jobs, the foundation, the walls, the roofings, and the finishing are what we are referring to as activities, So activity in a network is any job, is any work, is any task that consumes time and resources. So that's work, that job, that task that consumes time and resources, like digging the foundation, walls and roofing when you're constructing a house, what we are referring to as activities. Now, we also have sequence. Logical sequence means that to start which activity. So you have to understand first the different activities, the different jobs that are involved in a network for you to be able to draw the network. Now, we have understood what activities are. And again, because network, then we may also have what we call dummy activities. Dummy activities are actually non-existent and fictitious activities that are simply drawn so that we don't violate the rules of drawing network. Now, activities are actually denoted by arrow. They are denoted by the arrow, and the arrows move from left to right, as indicated here. And the arrows are not drawn to scale. So it is upon you to decide on the appropriate length of the arrow. So the arrow. Then the dummy activities we have said they are non-existent, non-existing activities, which are basically drawn so that we don't violate the rules of drawing network. So they are not listed with the real activities, but they only become necessary as the network is drawn so that we don't violate the rules of drawing network. So the dummy activities are indicated by dotted. To talk about events. An event is basically a point in time indicating when an activity is starting and when an activity is ending. For example, if their class is to start at 8, so this class starts at 8 a.m. and it may end at 10 a.m. Start of that class is an event. The end of that class is by a node or a circle as indicated there. So as I've said, an event is simply a point in time indicating when an activity is starting or when an activity is ending. So as basically I've indicated here, every activity must have what we call head events. There must be a tail event where the activity is starting. Of course, it is an arrow indicates where the work or the activity is starting, and the head of the activity indicates where where it is ending. Now, that's that. So I've said when you talk about network, just you just have to look at a simple example of constructing a house, and that's a project works that are to be done, and so those work that must be understood. Already explained them, may have foundation, digging the foundation, putting up the walls and the roofings and the finishing. Those tasks are eventually what makes up the complete house. Those tasks that are consuming time and resources are what we have said are referred to as activity. And those activities, as I've said, are indicated by arrows. And the arrows, basically, the tail of the arrow indicate when the activity is starting, and the head of the arrow indicates when the activity is ending. And they move from left, so the arrow actually move from left to right, and they are not drawn to scale. So that is to say that it is upon the candidate, the student, to determine the appropriate length of the arrow in the given situation. So that's that. Now, as I've said, when you are drawing a network, from left to right, and again, as a matter, as a rule of the thumb, on the activity from actually right to left. Now, each activity network can only have one point of entry, and also will only have one point exit. So in between, we may have several activities, but at one point of exit. So, and you can see the arrow there indicate the jobs, the tasks that are actually involved in that particular project. Now, that having been seen, in the network, we also have some other things that we need to understand. For example, we have a critical path, and a critical path is that is the longest, is a chain of activities with the longest time duration. So we shall see how it is determined as we actually draw a network. So for on what network is all about, you can look at the first example. So we shall be able to do it together. So the first example, Ujenzi Limited is constructing a dam whose activities and the estimated time duration. Given those details, the activities are A up to J. Those that are indicated as activities, they are the work, they are the tasks that are involved in the construction of these dams. And in most of the cases, we don't basically write, if it's the foundation, the walls, and the roof, we don't write the full names, but instead, we represent those tasks by letters. So those A, B, C, D, those letters represent the actual activities, the actual task, the actual jobs that are involved in the construction of that particular dam, as the equation basically has been provided. So, as I've already said, that we also have to understand the logical sequence of the activities that are there in the network, and the logical sequence basically determining what must start, what must end for another one to start, and so forth. Because if it is the building of the construction of the building, you cannot start with the roofing. That is not possible, and you can neither can you start with the walls. Just how to start with the digging of the foundation. After that is ended, then you can actually proceed to construct the walls, and after the wall has ended, you can proceed to do the roofing. That is a logical sequence that we are talking about here, and that is what has been captured in the definition: a combination of activities, dummy activities, and events in logical sequence according to the rules of drawing networks. So it means that as we are drawing the network, we must also take it. We must also not violate the rules that are of drawing a network. That's that. Now, we've been given those So you've been given that question. So you want to use this question to understand more on how we are able to draw a network. So you've been told draw a network diagram for the project, identify the critical path. And remember, I've said the critical path is simply a chain of activities with the longest time duration. So now we are going to see how it is determined when the network is being drawn, and then determine the project duration. So all this network, we may ask ourselves, why do we have to study network? It's important because it will assist planners to determine the costs which are involved in the whole project. They can also assist the planners to determine the resource requirement for a project, and so on and so forth. And that's why it is important for us to be able to understand the network. Now, an activity must start from somewhere, and that is an event. And we have said an event is represented by a circle, and it denotes the point in time when the activity is starting or ending. So each activity, there has to be a tail event and also a head event. And so we are starting activity A. You are seeing. We start with activity A, and then we have for activity B. There's no previous activity, so they start at the same time. We also have activity C. All those three activities are actually starting at the same time. Now, for activity D to start, A must end. So we are going to end A for us to be able to start D. And for activity E to start, A must also end. So all these are actually ending at the same time. So also we have E. So it means that the activity A, D, and E are sharing the same tail event. They are sharing the same tail event. It means that A must end for us to start D and E. Then we proceed and have for F to start, D must end. So for F to start, D must end D. So for us to start F, D must end. And for us, and E must end. So the preceding activity simply tells you those activities that must be ended for us to start the current activity. So for A to start, there's no preceding activities, and it means that is the one that we are starting with. For B to start, there's no preceding activity, neither to C. So those three activities are starting at the same time. Just like you can start by doing the fencing at the same time, somebody is actually clearing the compound, and somebody else, some other people are also doing the foundation. So they are starting at the same time. Then you've been told that for G to start, B and D must end. So B and D are not going to end. So you'll be forced to actually to be adjusting your working. So B and E are ending for us to start what we call, for us to start G. So B and E are B and E are sharing the same head event. So they are ending at the same time. So they must end for us to be able to start G. So then we've been told for H to start, F and G must end. So F and G must end. So this G. So these are ending. So for H to start. So for H to start, the two F and G must end. So it means that F and G as activities, and as I'm saying, the activities are basically the jobs or the tasks which are involved in a given project. So for us to start H, F and G must end. And every time we are ending, or every time we are starting an activity, we must have a node. It's because already we know what node is. A point in time indicating the start or finish of an activity. Then down there we say for I to start, C must end. So again, I there, for us to start I, E must end. And then for us to start J, I and H must end. So you can see here again, this is I. So we can extend this. This is I. So this is I and ending there. For us to start what we call J. So J is there. So, and this is the end of the network. So you can see we are simply step by step using the information provided. We have used the information provided step by step for us to be able to draw our network. So based on the information that we've been provided, this is how the network should be drawn. Now, having drawn this network, that is not the end of the question, because the question says draw a network diagram for the project. That is the first item. Then identify the critical path and then determine the project duration. So each activity A, as you have seen, it is to take 2 months. Or B, whatever it is to take 5 months. And so you've been given the restricting duration for the restricted activities going up to the last one, which is J. So you are supposed to use those informations for purpose of determining when are you likely to complete this project, so that you are done with the whole job. You are done with the construction of the dam. So in the construction of the dam, the jobs, the tasks which are all which are involved are actually the ones which are represented by A, B, and C. So in this case, on each inside each event, you put a sign that basically look like letter T that will assist you in the determination of the duration of the project. So in this regard, inside every event, you put that. And before you proceed and actually do anything, you must indicate the days, the duration for each activity. So for A, it is 2. For B, it is 5. For C, it is 4. For D, it is 3. For E, it is 8. And for D, for D, it is 3. For E, it is 8. For F, it is 2. So F is 2 months. G, it is 5. H, it is 7. I, it is 5. So I is actually 5. Where is I? So this I. So I was so this was I. So this was the I. So I is the 5. H was 7, and then J was 2. J was 2. So you have indicated the duration for each activity. So it will make it easier for you to be able to basically determine the duration. So as usual, when you are starting a project, you start from point 0. So we start from point 0, and then A will be able to end after 2 months. So 0 plus 2 is 2. Then C will be able to end after 4 months. So 0 plus 4 is 4. So indicate the duration as shown there. Then we have this node. B and E are ending on the same node. So where there are 2 activities converging at a given node, then you evaluate the duration along on those activities, and you along those paths, and then you pick the highest. So in this regard, on this we have 0 plus 5 is 5. We have 0 plus 2 is 2. 2 plus 8 is 10. So along this, if you take this path leading to this one, this node, it is 10 months. But straight away on B up to that point is 5 months. So we take the largest, which is 10. Again, we proceed. Now on this one, 2 plus 3 is 5. Again, if you look at this, there are 2 paths converging there. There's a path ADF, and there's also a path AEG. All we are converging there. So what we are doing, we call it forward pass. So forward pass, we are simply adding the durations for the respective activities along the given path. So we call that forward pass. Now, after we have reached at the end, then we shall be coming back when we are doing what we call a backward pass. So in the backward pass, we are subtracting, and we shall also see what happens in the backward pass where there are 2 paths converges at a point. So where 2 paths converges at a point, when it's backward pass, you evaluate and you take the least. But when it's forward, you evaluate and you take the largest. As we've seen here, we were taking the largest. 0 plus 2 was 2. 2 plus 8 was 10. But this one was 5. So we took 10. Now, in this case, this path, 10 plus 5 is 15. 5 plus 2 is 7. So we take 15, which is the largest. So you come here again with this another path. There's this path going here, and there's also this path ending here. So again, we evaluate 4 plus 5 is 9. Then 15 plus 2 is actually 22. So 22 is the largest, and therefore we take 22. And 22 plus 2 is actually 24. So this being the end, we write the 24 the other side, and we do what we call backward pass. So in the backward pass, we are simply subtracting the days as we basically go back to our original point. So 24 minus 2 is 22. So 22 minus 7 is 15. Again, we can use subtracting. 15 minus 2. 15 minus 2 is actually 13. We have 15 minus 5. 15 minus 5 is actually minus 5 is actually 10. Then we have this point is 22 minus 5. 22 minus 5 is actually 17. Then we have here, this is a point of convergence. So at that point of convergence, it is a backward pass. You evaluate all those paths and then you take the least. So in this particular case, 13 minus 3 is 10. 10 minus 8 is actually 2. So this was 13, that was 10. This was 10 minus 8 is actually 2. So 2 and 10, we take the least, which is 2. And then we get here, there are 3 paths leading to that particular node, that particular event. There's this path, and there's that path. And therefore, we evaluate all those 3 paths and we take the list. So in this particular case, 2 minus 2 is 0. 10 minus 5 is 5. 17 minus 4 is actually 13. So we pick 0, which is the least. So in this regard, you're able to see we are done. And the project duration is 24 months. So 24 months, as indicated there. And then we want to determine the critical path. We have said the critical path is a chain of activities with the largest time duration. So in this particular case, the easiest way for you to determine the critical path is to where those 2 items are actually similar. The start date and the end date are all similar. So if you look at this, we have 2, we have 10, we have 15, we have 22, and we have 24. So the critical path based on our analysis is basically A, E, G, H, and J. And the project duration, as you have said, you have determined there, is actually 24. That is that. So I hope we are together up to that extent. We have used that question determination of the project duration and in the drawing of the diagram, network diagram, and the determination of actually the critical path. So we want to proceed to look at the next question, and that is the second question. And with those 2 questions, then I believe you will be able to, you'll get a better position to tackle a network question that you may come across. So we'll proceed to the next, which is you've been told the following information relates to a project to be undertaken by a company. Now we know what a project is. And within a project, there are works or jobs to be done. And those works are jobs or all jobs which consume time and resources, and what we are referring to as activities. And we have said for purposes of drawing the network, those activities are represented by arrows, as we've seen there. So every arrow that you see in a network is an activity. So it means that if you are drawing a network and you just you draw without arrow, for example, you just have you have just that without these are not arrows. Then there's no arrow. Then essentially, there's nothing you are drawing there. Your diagram becomes wrong. So there must be arrows. In this regard, there are no arrows, and therefore, basically, your diagram is actually wrong. So you must clearly indicate that there are arrows, because, as we have said, the arrows are the indications of the activities. Now, just like in the last question that you have just looked at, also in this regard, these are the question you've been told, draw a network diagram of the project, and then you also determine the critical path and the project duration. So now, as we've said, always you'll be given the activities, and the activities are the jobs, and they are represented by letters. Then you'll be given the preceding activities that will assist you, enable you basically to logically draw the network by determining which activity has to end before you can actually be able to start the other one. And again, then the duration for which each activity is take or will always be given as indicated in the question. So we are starting. And as we usual when we are starting, we start with what we call a node or an event, a point in time indicating the start or of an activity. So there we have A and we also have B. So B and A are starting at the same point. And for us, the next is C. For C to start, B must end. So B must end for us to be able to start C. And then we told for D to start, A must end. So A must end for us to be able to start D. And then for E to start, A must also end. So there is also E here. D and E are starting at the same time, and it means they are sharing the same tail event, which is with the same tail event as we are seeing. So the A must end for us to be able to start D and E. And then the next, for F to start, C and E must end. So C and E must end for us to start F. So F and E and C are sharing what we call the same head event. Then for G to start, B must end. So for G to start, B must end. So again, for this, B must end because B must end there for us to start G. For H to start, D must end. So where is the D? So D must end there for us to be able to start. D must end for us to be able to start H. So H is there. Then for H to start, for I to start, the three activities must end. So E, H, G. So E, H, G. So you've been told I, F, H, H, G. Where is just a minute? So we have so for I to for G to start, there's for J to start. For J to start, there's G there. So J is actually ending at that. So J is actually ending. J is for G must end for us to start J. And then you've been told for I to start, F, H, and J must end. F, H, and J. So the three must end at the same time. So this is J. So this is H. So for us to be able to start I, so the three must end there. Then we have K to start, G must end. So for K to start, G must end. So we have to start K. So G is actually ending there. So G is ending there. So this is starting. We have starting K. So K to start, G must end. For L to start, I and K must end. I and K must end. So these are ending at the same time. So because there's one rule that two activities cannot share the same tail event and the same head event at the same time. So we have to avoid that. And the way we are going to avoid this is to introduce a dummy there. So we shall be introduce a dummy there so that we avoid that. So then L is actually going to start after that. We have L there. So that's how this network appears. So you can insert the duration. This is 7. This is 10. C is 15. D is 17. D is 17. E is 14. So we proceed. We look at insert the duration. G is 15. J is 12. H is 7. G is This is K. So K is K7. I is I was 11, and L was it was 9. So you can see from here A and B are starting from the very scratch. Then for C to start, B must end. We have seen that B must end for C to start. Then for D to start, A must end. D to start, A must end. Then for E to start, A must also end. Then for F to start, C and E. C and E must end. So C and E are actually sharing the same end event as indicated there. So for G to start, B must end. So again, for G to start, B must end. For H to start, D must end. So D is here. So for us to start that, D must end. For I to start, the 3 must end. H, F, J must end. And for J, of course, for J, G must end. And for K to start, also G must end. And lastly, for L to start, I and K must end. So that is a complete network. We've also indicated the duration. So you can then try to determine the project duration of the critical path by what we call forward pass and backward pass. So we start with the forward pass, and we start with the point 0. So 0 plus 7, that is 7. 0 plus 10, that is 10. And then we have a point of convergence here. So in this point of this point on this point, this event is this path leading to this place. There's another path. Path of AE is ending here, and also another path BC is also ending there. So we have to evaluate forward paths. We've said where the two paths or 3 paths or more are converging. We evaluate each path and then we pick on the largest path. So 7 plus 14 is actually 21. 10 plus 15 is 10 plus 15 is actually 25. So 25 is the largest, and therefore we pick on 25. Now 7 plus this was 10 plus 10. This is 7 plus 14 is 21. 10 plus that is 25. That's okay. Then we have 7 plus 17 here. 7 plus 17, this is 24. Then we have this 10 plus 15 is 25 here. And then we also have a point of convergence here. There are 3 paths all leading to that. So again, we evaluate 24 plus 7, that is 31. Then we have 25 plus 9, that is 24, that is 35. Then we have 25 plus 12, that is 37. So 37 is the largest, we take 37. Then this also a point of convergence. 37 plus 11 is 48. 25 plus 7 is actually 32. So we take the biggest, which is 45. So 48, I mean. So 48 plus 9, that is 57. So the duration for this particular project is actually 57. So we can go do backward pass, and that will be able to assist us in the determination of the critical path. So 57 minus that, minus 9 is 48. 48 minus 11 is 37. Then this is a point of convergence. So we have 48 minus 7, that's 41. 37 minus 12. 37 minus 12 is actually 25. So this is 25 there, because we pick the list when we are doing the backward pass. Now, 37 minus 9, that is 28. That is 28. This is 28. 37 minus 7, that is 30. Then again, there's a point of convergence here. We pick the list. So 25 minus that is 10. 28 minus 15 is actually 13. So we pick 10. Then we have 30. This is also a point of convergence. So 30 minus 17, that is 13. 28 minus 14 is actually 14. So 14, this one is 13. So we pick on 13. Then there's a point of convergence here. 10 minus 10 is 0. 13 minus 7 is actually 6. So we pick on 0. Now, that is that, and therefore we want to see which is the critical path. So we are able to see clearly that the critical path in this case is B, C, F, I, and finally L. And the duration, as you have said, is actually 57. So it may be given in days, it may be given in weeks. So the duration is actually 57 weeks. So that's that. That's how this network is actually done. So with the discussion that we have had today, and also by looking at the two questions on network that we have discussed, I believe that you are now in a better position to tackle any network problem that you may be given across, that you may be given by any question. You are able to actually get all the marks. So with that, we come to the end of our class. Until next time, bye for now.